स्टार्ट करिए। गुड मॉर्निंग एवरीवन, कैसे हैं आप सब लोग? गुड मॉर्निंग टू ऑल ऑफ यू। चलिए, आई वांट ऑल ऑफ यू टू जस्ट put a comment so that I can understand whether audio and video is clear to all of you or not. Quickly, all of you, those who are here. Morning, Sahbaj. Morning, good morning. Please let me know whether my voice is clear or not. As this is a new channel, so in starting it takes little bit time, but no problem. Now we can start our practice part. So first of all, this is the first class for this Super 10 question series. And in this question series, what we are going to do, we are going to solve 10 questions of everyone's favorite, like my favorite 10 questions here for environment. You guys need to go for the practice, and if any doubt comes in between, you have to ask. Is it clear to all of you? Shall we start with the first question? All of you. I want reply from all of you. Shall we start with the first question? Morning. Good morning to all of you. Good morning. Okay. So let's start with the first question, Misha. Let's start with the first question. So here's the question for you. These are the statement which is given to you. Common data question it is. A 200 ml of sample of water has an initial pH of 10. 30 ml of 0.02 normality H2SO4 is required. Titrate the sample to pH 4.5. If pH equal to 8.3 is increased at 11 ml of AC. Maths is going on. Oh, I'm not aware of this part. No problem, no problem. Those who are not here, they can watch it as a recorded, so don't worry. But live will be always a better option. चलिए, क्वेश्चन में आप लोग को स्टेटमेंट in this statement is clear to all of you. Now, what first thing they are asking you in this question? The concentration of OH minus in milligram per liter as a CaCO3. The first thing in this question, what they are asking you. So, if you understand the question properly, what they are telling you that it's a volume of sample is volume of sample is nothing but 200 ml. Volume of sample is nothing but 200 ml. Now, water has initial pH of 10. So, initial pH of water is pH is equal to 10. Okay. 30 ml of 0.02. So, that is the remaining part of that. But first thing your question, the first thing what this question is asking about is that the concentration of OH minus in milligram per liter as a CaCO3. Now, if you understand that part, pH is 10. That means POH is what? 4. I don't think so anybody will have any problem in this part, because you all know that pH plus POH is 14. So if pH is 10, POH will be 4 only. Now if POH is 4, what will be the OH minus concentration? 10 to the power minus 4 mole per liter. Is it clear? So once you have OH minus concentration in mole per liter, you all can convert that into the milligram per liter. Simply, first you need to multiply 10 to the power minus 4 mole per liter. So 1 mole of OH will be 17 gram. 1 mole of OH will be 17 gram. Now 16 plus 1, it will be 17 gram. Now it will be in gram per liter. Now we want in milligram per liter. So multiply by 1000. So now this value is in milligram per liter. But the problem is that this question they are asking OH value, they are asking this OH value milligram as CaCO3. In terms of CaCO3, they are asking you. In terms of CaCO3, they are asking. Is that clear? Now understand this point. If OH minus is 10 to power minus 4, 17 into 1000 milligram per liter, if you want to represent this value in terms of any other substance, in that case, what you will do? You will first change this part in gram equivalence. That means what? You will divide by, I'm writing in this next slide. So we have OH minus concentration. We have OH minus concentration 10 to the power minus 4 into 17 into 1000. It is in milligram per liter. So what I'm doing, first I'm converting this part into gram equivalence. So I'm just dividing by the equivalent weight of OH minus, and that is nothing but the 17. So we got the gram equivalence part. Once you got the gram equivalence part, in that case, now if you want to convert, if you want to represent this value in any terms, what you will do, you will just multiply that value with the equivalent weight of that substance, like for whatever substance you are representing. So right now we are representing that value in terms of calcium carbonate. So we have multiplied by equivalent weight of calcium carbonate, that is nothing but 50. So now let us cancel all those things. So 17 and 17 will get cancelled out. This will be 10 to the power minus 4 into 10 to the power 3. It will be 10 to the power minus 1 into 50. Ultimately, what we are getting, 5 milligram per liter as CaCO3. As a CaCO3. So in that case, your answer will be option C without any doubt. I hope it is clear to all of you. I hope it is clear to all of you. Is it clear? So the first part of this question is clear to all of you, my dear. Second part, what they are asking you is the concentration of CO2 minus. Okay. Now again, we'll read the second line of the question. What they are telling, that 30 ml of 0.02 normality NH2SO4 solution required to titrate the sample to pH 4.5. Okay. If pH is 8.3, is reached in 11 ml of acid. We'll understand each and every part in detail. First of all, see, for 200 ml, we need 30 ml of 0.02 NH2SO4 solution. So generally we represent our value in per liter. So for 1 liter, how much titration will be required? How much titrant will be required? So 200 ml sample require. I'm writing each and everything so you all can understand in recorded format also. 200 ml sample require 30 ml of 0.02 NH2SO4 solution. So 1 will be 30 upon 200, and here we are for 1 liter, that means 1000 ml sample. So it will be 30 divided by 200 into 1000. So it will be nothing but 150 milligram per liter. 150 milligram per 150 ml of 0.02 NH2SO4. Okay, is that clear to all of you? So total we have 150 ml of 0.02 NH2SO4. That much titrant will be required. Okay, now what we can do here, extra slide. So now understand here, we have 150 ml of 0.02 NH2SO4. Now if you all know that 1 ml of 0.02 NH2SO4 is equal to 1 ml of alkalinity. This already I have taught in class also how this things comes. 1 ml of alkalinity in terms of calcium carbonate. In terms of calcium carbonate. In terms of calcium carbonate. So 1 ml of 0.02 normality NH2SO4 equal to 1 ml of alkalinity in terms of calcium carbonate. I think that is clear to all of you. Now that means total alkalinity will be 150 sorry, will be 1 milligram, no? So 150 milligram per liter of alkalinity as CaCO3. We got the total alkalinity basically. We got the total alkalinity. Okay. Now total alkalinity means what? It will be OH minus plus CO3 2 minus plus SCO3. These are equal to nothing but 150. Okay. Now in this question, what they are telling in second, I think last line, if you did, but to H8.3, 11 ml of acid will be required. Now you know that those who have studied the titration curve, they know that this titration curve is like this. At 8.3 pH, till here, caustic alkalinity completely plus half carbonate alkalinity will be removed. This thing you guys are already knowing. So in that case, if 11 ml is required for 200 ml sample, so for 1000 again it will be 55 ml. So I'm writing that part. So that means at 8.3, 55 ml of alkalinity, 55 ml of 0.02 NH2SO4 solution, titrant is required 55 ml of 0.02 NH2SO4 titrant is required for 1000 ml sample, and that will give you OH minus plus half CO3 2 minus alkalinity is nothing but equal to 55 milligram per liter as CaCO3. Same with the same concept we have done this. OH minus plus half CO3 2 minus is 55 milligram per liter as CaCO3. That is clear to all of you. Now if you understand the next part, total alkalinity we have OH minus plus CO3 2 minus plus SCO3, that we have 150. OH itself is 5. Okay. And another equation we have OH minus plus half CO3 2 minus, that's something we have 50 milligram per liter. Sorry, 55, not 50. 55 milligram per liter. OH already we have already calculated, so that is 5. So that means half CO3 2 minus will be equal to 55 minus 5. So CO3 2 minus will be equal to 50 milligram per liter as CaCO3. Is that clear? So carbonate alkalinity we already calculated as 50 milligram per liter as CaCO3. Okay. Now once you got the carbonate alkalinity, sorry, it will be 100, no, not 50. It will be 100. 50 into 2, 100. So we got carbonate alkalinity 100. We got OH alkalinity 5. In that case, the remaining SCO3 will be what? Total alkalinity we have 150 minus 5 minus 100. It will be 45 milligram per liter as CaCO3. That means what? Our right answer for this question will be First, for CaCO3, the right answer will be 100. And the next part for SCO3, the last part of this question, is the right answer will be 45 milligram per liter. I hope it is clear to all of you. I hope it is clear to all of you. Is that clear? We are going for the next question. If you have any doubt, you can ask. Going for the question is in 2 slides. So first slide is this. Kindly note down all the given data. Then I will show you the next slide. Then I will show you the next slide. Then I will show you the next slide. This is what they are asking you. For 100 ml, and these are the these are the standard table data which is given to you. So this one is nothing but the test sample, like for 531. These are the sample dilution, and these are the number of positive and negative test results. Number of positive and negative. So 531, and here this is the standard sample. The direct question, I think you all can solve it quickly. You all can solve this very quickly. It's a simple question. Whenever we see this type of question, the first thing what we see, test sample, what is the dilution? So that is 0.01, 0.001, 0.000, it will be one more 0, 1. This will be the dilution. From test sample to standard sample, if you go, from test sample to standard sample, if you go, what you need to do, multiply these value, like 10 divided by 0.01, 100. So it will be 1000 value. It will be 1000 value. So that means from test sample to standard sample, you need to multiply 1000 with the value whatever you are getting in the standard sample. So for 531, positive value we have 531. For that, the standard sample is given that the value of MPN will be 110, 110. But as you know that the test sample dilution and the standard sample dilution is different, and how much time it is different? 1000 time it is different. That means the whatever value we have to multiply by 1000 to get the right answer. In that case, MPN will be 110 into 1000. MPN equal to 110 into 1000. It will be D option. 110 and 1000. Okay. So right answer for this question will be option D. I hope it is clear to all of you. MPN, generally people have doubt about this question, but this question is very easy. Within 2 minutes, you all can solve this question. Within 2 minutes, you all can solve this question. If anybody having any doubt in this question, please let me know. Otherwise, we'll go to the next problem. Next problem. A dose of 1 milligram of chlorine. Dose of 1 milligram of chlorine is necessary for satisfactory disinfection of water at pH 7. And the corresponding contact time required is 15 minutes. The concentration of disinfectant and the time required are related as C to the power 1.5 T equal to M, where M is a constant. The ionization constant Ki is 0.7 into 10 to the power minus 8 mole per liter. Mole per. These are the given data. Question will be in the next slide. Put down each and everything. Note down each and everything. Then we'll go to the question part. Then we will go to the question part. First question is the doses of chlorine at pH 8 will be. Doses of chlorine at pH 8 will be. First thing first. Doses of chlorine pH 8 will be. Okay. So question what they have mentioned that Cl2 dose for pH 7 is 1 milligram per liter. And if you are changing the pH value, what will happen? The concentration of HOCl will change and accordingly the Cl2 dose will also change. Now you all guys are knowing a relation which I already gave it to you is that Cl2 demand, yeah, you can write like this, concentration of HOCl is equal to Cl2 dose into percentage HOCl. If you elaborate this part, it will be Cl2 dose into percentage HOCl. We can write 1 upon 1 plus K upon H plus into 100. This will be the percentage HOCl. Now, if you understand, for a given efficiency, as in this question, they have not given that efficiency is going to change. So we'll take efficiency as a constant. So for a given efficiency, this concentration of HOCl will be constant. If you are changing a pH, if you are changing the pH, H plus concentration will change. Accordingly, a percentage HOCl will change, and accordingly Cl2 dose will change. But this multiplication of these two will be always constant. And this is the concept which we are going to use in this question. So here they have mentioned that pH will be 7, and what they're asking here is for pH 8. Okay, so let's do it fast. First Cl2 dose we have for pH 7 we have 1 milligram. So 1 milligram per liter into percentage HOCl for first case. So 1 upon K upon H plus. If they have given you 2.7 to 10 to power minus 8 divided by 10 to the power minus 7. That is the H plus concentration. That is the H plus concentration. Equal to, for second case, Cl2 dose is not mentioned. For second case, Cl2 dose is not mentioned. Into 1 upon 1 plus K upon H plus. K we have 2.7 into 10 to the power minus 8 divided by here this time pH we have 8, so it will be 10 to the power minus 8. Okay. So now if you solve this part, Cl2 dose, how much we are getting? You all can do it. You all can do it. Solve कीजिए. Now it's a simple calculation. 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 Do it, everyone. roughly I think we are getting around 2.92. एक बार check कर लीजिएगा. Like I'm not completely sure about. You are not giving any options. So I think 2.92 milligram per liter will be the right answer for this. Now the second part of this question is that if pH value is 8 and the dosage of 1 milligram per liter, the contact time required is. What they're telling is that, okay, so I am changing the pH concentration. I am changing the pH value from 7 to 8, but I don't want to change the doses. It will be still 1 milligram per liter only. But in that case, what we need to change? We need to change the contact time. Simple, so you all know that C and N relation, C power N into 2 equal to K. That means if you are giving more concentration, less contact time will be required. If you are giving more contact time, less concentration will be required. So if someone is restricting you related to the concentration part, you can change the contact time for the given efficiency, for the desired efficiency. That's what I'm going to do in this question. So here we will use T to the power N into T equal to K relation. I think this question N value is mentioned to you. It is 1.5. It is 1.5. So it is C to the power 1.5 into T equal to K. Now for the first case, we have pH values. We have how much? Concentration is 1. So 1 to the power 1.5 into contact time. Contact time they have mentioned here is nothing. 15. Okay. So for second case, we have 2.92 concentration which is required to the power 1.5 into contact time we have 15 minutes. Now if you want concentration dose to be 1 to the power 1.5 into contact time, you need to find out. So if you calculate T, how much you are getting, please let me know. Basically you need to multiply these. कितनी वैल्यू आ रही है एक बार बताइए कमेंट करके. I don't have any calculator, so you guys have to do it. 2.92 to the power 1.5 into 15. This 1 to the power 1.5 will be 1 only. Directly this multiplication we need. This multiplication we need. This multiplication we need. This multiplication we need. Roughly we'll get around 74. Roughly we'll get around 0.65. Roughly we'll get around 74 point. Okay. Try the next question. Try the next question. Try the next question. In this question, what they're telling, at a small water treatment plant which has 4 filters, the rate of filtration and backwashing are 200 meter cube per day per meter square and 1000 meter cube per day per meter square respectively. Backwashing is done for 15 minutes per day. The maturation which occurs initially as the filter is put back into service after cleaning takes 30 minutes. It is proposed to recover the water being wasted during backwashing and maturation. The percentage increase the filter water production. Simple question. You all can try. Okay. So I hope you guys have tried. Now in this question, what they're telling, a small water treatment plant which has 4 filters, the rate of filtration and backwashing is given to you. So first write down all these things. ROF we have 200 meter cube per day per meter square. And ROB we have 1000 meter cube per day per meter square. Okay. Backwashing is done for 15 minutes per day. So DOB, duration of backwashing is 15 minutes. The maturation which occurs initially as the filter is put back into service after cleaning takes 30 minutes. So we have duration of maturations, that is 30 minutes. That is 30 minutes. It is proposed to recover the water being wasted during backwashing and maturation. The percentage increase the filter water produced. Percentage increase, what they're asking you is percentage increase Okay. So first we'll calculate each and everything. So let us say out of 24 hour, 15 minutes is going for the backwashing and 30 minutes is going for the maturation. So remaining time for duration of filtration will be what? 23 hour 15 minute. Okay. So that I am changing as 23 hour. Sorry. 15 divided by 60. It will be 1 by 4, 23.25 hours. 23.25 hours. Okay. Is that clear? So now we have duration of filtration also with us. Let's calculate the first part. Amount of filtered water. So it will be ROF into DOF. This question they have not mentioned area, I think. So if they have not mentioned area, we'll take as 1 unit. So we are multiplying with 1 unit area. So ROF we have 200. Unit we have cube per meter square. Into DOF we have 23.25. Okay. So it will be in hour. We need to convert into day by dividing by 20. Whatever you are getting, that will be the amount of filter water used. Now amount of water used for backwash. Amount of water used. So we have ROB into DOB. Again, 1 unit area we are taking. So DOB we have 15 minutes. So I'm converting this part into hours. 15 divided by 60. 15 divided by 60. But 1 by 4 hour. Now this is in day. So I'm again dividing by 24. So to be value आएगी whatever you are getting. Next, amount of water used in maturation. Amount of water used in maturation. Amount of water used in maturation will be ROF, because you know that during maturation rate of filtration is going on. So ROF into DOF into 1 unit area. Thousand into DOF, we have how much we have? DOF, how much we have? DOF, duration of filtration, we have sorry, duration of maturation, na? So that we have given 30 minutes if I'm not wrong. Convert that part into hours, so it will be 1 by 2 hour. Again convert in days. So 1 by 2 divided by 24. So whatever you are getting, that will be the answer. Calculate each and everything. I don't have any calculator, so I want you guys to solve. So first we have 200 into 23.5 divided by 24. So first thing we got 195.83. First part we got. Second, 1000 into 15, 1000 into 15 divided by 60 divided by 24, 10.416. So 1000 into 0.5 divided by 24, 20.83. 20.83. Okay. So now what they're telling in this question part is that it is proposed to recover the water being wasted during backwashing and maturation. They want to recover that part. So okay, so and the percentage increase in filtered water produced is. So if they want to recover that part, let us take extra slide again. Let us take extra slide again. So in that case, if water if water being used water being used if water being used for backwashing and maturation is recovered, so total amount of filtered will be what? Previously it was something 195 something. So total amount of filtered water previously we have 195.83 195.83 plus we have 20.83 plus 10.4. How much we are getting? So 195.83 plus 20.83 plus 10.416. So we got 227 something. 27.0. This much amount we are getting. It is if the water is being used for backwashing and maturation, this much amount we are getting. This much amount we are getting. Water is being used for backwashing and maturation is for covering that part. So percentage increase will be what? It will be 227.076 minus 195.83 divided by 195.83. 227.076 195.83 divided by 195.83. Think. Let me read this question again. Proposed for the water being wasted during backwashing and maturation. Okay. We have done a small mistake na here. It will be 200 na, not 1.2, not 1000. 200, that is the rate of filtration. That is 200 rate of filtration. Need to calculate it again. So 100 divided by 24. 4.16. Now add this 0.1. कितनी आ रही है? How much we are getting? 195.83 plus 4.16 plus 10.416. So we are getting 210.40. There was a small error in calculation. Kindly everyone correct that part. So 21.406 minus 195.83, 14.576 divided by 195.83 into 1000, into, if you 100 into 2, somewhere around 7.44 percentage. So roughly we can say 7.53 or 7.44. Roughly you will get. Okay. I hope this question is clear to all of you. Please tell me fast. That question, it's something which is clear to all of you. Is it something which is clear to all of you? If you want, you can give much more accurate value also. If you want to calculate it in much more, actually you can do here is that total amount whatever you are getting 195.83, total amount whatever you are getting, amount of filter, backwashing water will what? It will come from that only, na? So you can actually amount of water filter will be, actual amount of water filter will be, I'm adding one extra slide. Someone is asking you much more accurate value. But okay, let us leave that part. You will get confused. Basically what I'm telling you that actually the amount of water for backwashing actually comes from the filter water only. Okay, so actually what will happen, the amount of filter, the exact amount of filter water what we are getting, that will be amount of filter water like 195 something we got minus backwashing water 10 point something. So that will be the another level of this question. In that case you are getting much more accurate data. So that also you can do if you want. Okay. Try the next question.